Okay, here we go. So, yeah, wasn't going to do a video today, but I just had the urge to talk about general relativity again because I got into a little bit of discussion. And there's a lot more evidence for the variable speed of light than what people realize. And it's because of general relativity that there is a variable speed of light. Because general relativity demands that you have a variable speed of light because general relativity changes the measure of time and distance, changes the rate of time, and it changes the measure of distance. Both of which combined change the speed of light. You can't change the measurements, the parameters to measure the speed of light without changing the speed of light. If you're using a cubit to build a house, the size of the cubit is going to make a difference in the size of the house. So a cubit is, the size from here to here, right? That's a cubit. That's the exact cubit that Ken Ham used to make his ark down in Kentucky. But the point being is that you change that measure, you're going to change the size of the ark or the house that you build with it. If you follow the measurements. And this is what's happened in general relativity because not only the size is changing, the rate of time is changing, which together they combine to change the rate of causation. In other words, things happen at a faster rate. Things occur at a faster rate. That is what general relativity says. Okay, so I'm going to run through this video again because I don't know if everybody saw the video, but let's go ahead and watch this video a little bit and see where it goes here. So we'll just add this here and we'll zoom up here and we'll back this up here if I can back it up. Okay, and we'll start.
In 1905, Einstein developed his theory of special relativity. It was an explanation of how speed affects mass, time, and space. It included a way for the speed of light to define the relationship between energy and matter. In it, he defined that the speed of light was constant. What many people may not be aware of is that Einstein did not hold this view for long, and would start to develop.
Okay, so the speed of light is constant as long as your measurements of time and distance are constant. Now let's check this out.
Develop a theory which would allow for a variable speed of light. Let's dive in and find out more. 2 years after publishing his paper on special relativity from it. These equations too have the same for gravitation-free space. However, C is here replaced by the value C open brackets 1 plus gamma xi over C squared close brackets is equal to C open brackets 1 plus phi over C squared close brackets. From this, axes are bent by the gravitational field. This shows his thinking towards a concept where the velocity of light is altered by the gravitational potential. In 1911, he wrote.
Okay, think of it as a lens. This is the way I think of it, and I explain it, is that you have a lens, a glass lens, which slows down light because of the glass. When you have a magnifying glass, which is what gravitational lensing is, it magnifies objects, things in space. In a glass lens, the thicker part is in the middle. So the thicker part is going to slow down light more than the thinner edges of the glass, which slow down light less, resulting in a magnification, which is what gravitational lensing is. It's the exact same principle. Where gravity is stronger, light slows down more in the center. Where gravity is weaker, light slows down less. And that is what causes the gravitational lensing.
Wrote a paper on the influence of gravity on the propagation of light and said the following. If C0 denotes velocity of light at a
They're showing that you can't have a constancy of the velocity of light. And he's showing mathematically that you can't have a constant speed of light. So he goes on to explain throughout the year, this is 1911, goes on to explain throughout the years, and people just didn't hear what he said, ignored what he said, or didn't understand what he was saying, because you have to go through with a thought experiment. You have to think through what the ramifications are, the ramifications of the variable speed of light. You have to think through what the conditions are.
Some might claim that Einstein developed his theory of the variable speed of light and then abandoned it. But if we follow his writings, we find he keeps going on about this point. In 1912, he wrote, "On the other hand, I am of the view that the principle of the constancy of the velocity of light can be maintained only insofar as one restricts oneself to the spatio-temporal regions of constant gravitational
potential." Did you see that? It's only constant if there's a constant gravitational potential. If the gravity changes, the amount of gravity changes, and it changes throughout space, especially when you're looking at a galaxy, you're not looking at a single rate of time or a single measure of distance. You're looking across vast distances where the gravity changes. The amount of gravity changes, so the measures of time and distance change in your line of sight when you look at it. It's not like looking at a cat or a dog on Earth. It's not like looking locally with a constant gravitational potential, because there's the variable gravity means that there's a variable speed of light.
potential. A little later, in 1913, he wrote, "I arrived at the results that the velocity of light is not to be regarded as independent of the gravitational potential. Thus, the principle of the constancy of the velocity of light is incompatible with the equivalence hypothesis." Then later in 1914, in the case where we drop the postulate of the constancy of the velocity of light, there exists a priori no privileged coordinate system. Then in 1915, the writer of these lines is of the opinion that the theory of relativity is still in need of generalization, in the sense that the principle of the constancy of the velocity of light is to be abandoned.
The principle of the constancy of the speed of light needs to be abandoned. It's only constant mathematically or numerically because the speed of light never changes, but the measures of time and distance change, which changes the speed of light. You cannot change a measure to measure light and not have the speed of light change, because the way you measure speed is with time and distance. And if you change those measures, if they stretch or contract or go faster or slower, in the case of time, you're going to change the speed of light. And that's exactly what's happening. General relativity demands a variable speed of light depending on the gravitational potential, how much gravity there is where the light is passing through.
Then in 1916, in the second place, our results show that, according to the general theory of relativity, the law of constancy of the velocity of light in vacuo, which constitutes one of the two fundamental assumptions in the special theory of relativity, and to which we have already frequently referred, cannot claim any unlimited validity. A curvature of rays of light can only take place when the velocity of propagation of light varies with position.
So you can only have a curvature, like as in gravitational lensing, you can only have a curvature of light where there's a variable speed of light. That's what he just said.
And then in 1920, second, this consequence shows that the law of constancy of the speed of light no longer holds, according to the general theory of relativity in spaces that have gravitational fields. As a simple geometric consideration shows, the curvature of light rays occurs only in spaces where the speed of light is spatially variable.
The curvature of light rays occurs only in spaces where the speed of light is spatially variable. Again, he's talking about this lens effect, this bending of the light wave. It's not just bending the light waves, it's changing the speed of light. Of course, he went through the thought experiments, the same thought experiments that I went through before I even saw this video, before I even knew that Einstein was talking about the variable speed of light. I was talking about it for years now. And it's not only that the rate of time changes, it's the rate of distance also changes, which is what we might see here in a little bit.
Einstein's ideas remained relatively unknown because of a series of coincidences. In 1919, Eddington's solar eclipse observations were seen as confirmation of Einstein's 1915 form of general relativity, where the curvature of space-time causes a bending of the light. This overshadowed Einstein's continued efforts to have a variable speed of light. In Einstein's variable speed of light, the bending is caused by the gravitational gradient, much like that of light, which is refracted in a dense medium. Einstein attempted to calculate the deviation using his variable speed of light theory, but as he had not considered length scales, he got the incorrect value.
See, he, like many other people, did not consider the length scales. It's not just time that's changing, it's the distance that changes too, both of which compound the change of the speed of light depending on how much gravity there is. This is what I've been saying for like years now.
It would take until 1957 for Robert Dicke to spot the mistake. In that paper, Dicke remarked that when he included the length scales, the variable speed of light formulation of general relativity was in agreement with the classical tests. In the period from
So it's an agreement with the observations. So here 100 years ago, Einstein was talking about the variable speed of light. 100 years ago. It's 1920s. And people today still don't understand what he was talking about.
From the 1920s until the 1960s, relativistic physics was in hibernation, mainly due to the fact that the theoretical work had outstripped technology and experimental possibilities, and, as a consequence, the field stagnated and was relegated to the backwaters of physics and astronomy. In 1964, Erwin Shapiro wrote an article about the fourth test of general relativity and said the following. Because, according to the general theory, the speed of light waves depends on the strength of the gravitational potential along its path, these time delays should thereby increase by almost 10 to the minus 4 seconds when the radar pulse passes near the Sun. Such a change equivalent to 60 kilometers in distance, could now be measured over the required path length to within about 5 to 10% with presently obtained equipment.
Okay, so the video goes on. I can't play the whole video. I don't have time, but I just wanted to show that all my thought experiments that I've been doing were done over 100 years ago. Or except that I included the distance dilation, the change in distance, to which increases the rate of causality the farther away you get from the center of a galaxy, from the mass of the galaxy. That's the reason, this is the reason why the outer spiral arms move faster than they expect, but eventually the tendency is for everything to slow down. So farther than the outer spiral arms, stars start moving slower again, because the tendency is just to keep on slowing down because it's less and less gravity. But the causation is still fast. And if you get outside of a galaxy, between galaxies, then the causation is even faster. And because gravity drops off considerably, the farther away you get from the center of the galaxy, the more gravity drops off, and the faster the rate of causation is. So, anyways, that's about it, I guess, for today. Today's lesson. Here we go. I just had to get in another video about the variable speed of light and see if, especially creationists, should be jumping on this because it explains how light from distant stars can reach us in 6,000 years. If there's a faster rate of causation, time passes by faster between galaxies, and distance is expanded, means the distance isn't as far to begin with. I mean, because the more distance is expanded, the more or the less units of measure of distance there is between here and distant galaxies. So the less units of measure between here and there means less distance, even though the distance is stretched. So it's still far away, but mathematically it's less distant, meaning that the light travels faster. so everything combined, means a variable speed of light, means this is the reason why we can see distant starlight. So, no, creationists need to be on top of this because this is what general relativity demands. It demands a variable speed of light, and a variable speed of light is what we need to explain. It explains everything. Dark matter explains everything. Dark energy is due to the black holes that are absorbing space-time. That causes the vacuum energy because the black holes are the most powerful things in the universe. The energy, the power, is being exerted on space-time by absorbing space-time in the black holes. This is what's causing the vacuum energy. It's not, the universe is not expanding into oblivion for no reason. You have to have a reason. If the universe is expanding faster and faster and faster, you have to have a source and a cause for it. But people are misinterpreting what the evidence that we see. So we can get everything straight if we just look at the observational evidence, what we can verify that happens, verify what happens when we consider only what can be verified. So God bless everybody. Take care and stay close to the truth, because the truth will see us through. And who's the laughing stock? Who's the laughing stock of now? Young Earth creationists, or is it the old Earth scientists? Who's the laughing stock now? Because matter is such that it has to be made. It can't make itself. So if matter was made, that means there's a point in time where matter was made, and that is the creation, like the Bible says, just over 6,000 years ago. That was the point matter was created, because there has to be a time where matter was created. And with looking at all the evidence that we have, matter was created just over 6,000 years. So who's the laughing stock now? God bless everybody. Take care.